Welcome back everyone. In this tutorial, we need to test a hypothesis when we have two independent samples and the population variances is none. And we are going to use the same business scenario when we have two groups of students, one from school A and one from school B. And we want to check here if there is any difference between the grades in school A and the grades of school B. So what is our hypothesis? The hypothesis here say school B outperformed school A by 8%. The average grades in school B is higher than the average grades in school B by 8%. The alternative hypothesis that we want to test is mu A minus mu B equal minus 8%. Mu A is the population average grades in school A, and mu B is the population average grades in school B. So when we say mu A minus mu B equal minus 8%, that means the students in school B outperformed the students in school A by 8%. And we can swap these two if we want. We can say mu B minus mu A equal 8%. So we can get rid of the minus if we want. And the opposite here in the null hypothesis. So mu A minus mu B doesn't equal minus 8%. So let's switch to Microsoft Excel to test this hypothesis. Because the observations of the two samples are greater than 30 observations and the standard deviation is given for both of them, we can use the distribution test. And this is the formula. x1 bar minus x2 bars means the difference between the two sample means, which is minus 6%, minus mu1 minus mu2. And this is what we want to test here, which is minus 8%, divided by square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. And you already found this value from a previous tutorial. So the variance difference is 0.005. The standard error difference is 2.25%. So minus 6% minus 8% divided by 2.25%, which is the standard error. And based on that, Z value equal 0.89. And because we are testing this hypothesis in 95% confidence level, and it is two-tailed hypothesis, we are going to use Z by 2, which is Z.025, which equal 1.96. So let's see if we are going to accept or reject the hypothesis. We have 1.96 on the right and minus 1.96 on the left. And the value we found is 89%, which is located in this area where we don't reject null, we accept null. That means we don't have a significant evidence students in school B outperform students in school A. You can use p-value calculator to get the same results. The p-value we found from the online calculator is 0.373466, which is much bigger than 5%. So the result is not significant at p less than 5%. So the interpretation here is there is no significant statistical evidence at the confidence level 95% that students in school B outperform students in school A by 8%.